Early December 1944. The muddy airfield at Tacloban, Leyte Island, Philippines. A Type 97 fighter sat crumpled at the edge of the runway, its landing gear collapsed, fuselage torn open by machine gun fire. Japanese intelligence officers from the Imperial Army's Technical Research Division approached the wreckage with methodical precision, cameras and measurement tools already in hand. But they weren't interested in the aircraft. Draped across the pilot's seat, still attached to its harness, was an American T-5 parachute assembly, intact, undamaged, and completely different from anything Japanese paratroopers carried. This single piece of equipment, captured during a failed strafing run against a C-47 transport dropping supplies to Filipino resistance fighters, would trigger a sobering assessment among Japanese military planners about the widening technological gap between American and Japanese airborne forces. The parachute bore manufacturing stamps from the Pioneer Parachute Company of Manchester, Connecticut, serial number PT-421873, manufactured in July 1944 and issued to the 511th Parachute Infantry Regiment, 11th Airborne Division. What Japanese engineers discovered through careful examination of this equipment would force them to confront uncomfortable truths about American industrial sophistication and their own military's failure to prioritize paratrooper welfare with the same systematic attention to detail. The mathematics of airborne warfare were about to be rewritten, not through superior tactics or training, but through something the Japanese military had never emphasized: engineering excellence focused on soldier survival and operational effectiveness rather than minimal acceptable functionality. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Lieutenant Colonel Hayashi Takeo supervised the initial examination at Tacloban before the parachute was crated for shipment to the Army Technical Research Institute in Tokyo. Hayashi had commanded Japanese paratroop operations during the Palembang oil field assault in February 1942, where Japanese forces successfully captured vital Dutch facilities in Sumatra. He understood parachute equipment intimately, having made 17 operational jumps himself during training and combat operations. What he saw in the American parachute contradicted every assumption Japanese military planners had made about acceptable design trade-offs in airborne equipment. The T-5 parachute system weighed approximately 31 pounds, complete with harness, reserve chute, and deployment bag. Japanese Type 98 parachutes, by comparison, weighed approximately 24 pounds for the main assembly. This 7-pound difference seemed significant until engineers examined what that additional weight purchased in terms of reliability and soldier safety. The American canopy used 28 panels of tightly woven silk, each panel precisely cut and double-stitched with reinforced seams. Japanese parachutes used 24 panels with single-stitch construction to save time and material. The suspension lines on the T-5 parachute numbered 28, each rated for 550 pounds of tensile strength, manufactured from nylon that had become standard in American production since 1942. Japanese parachutes used 20 lines of silk cord rated for 400 pounds each. Nylon manufacturing in Japan remained experimental and limited to small-scale laboratory production. The harness system revealed even more dramatic differences. The American T-5 employed a quick-release box design that allowed paratroopers to disconnect all attachment points simultaneously by rotating a single metal disc. Japanese harnesses required unbuckling 3 separate connection points individually, a process that added precious seconds during landing when enemy fire made speed essential. The reserve parachute, worn on the chest in American configuration, represented technology Japanese forces had discussed but never implemented due to material and weight constraints. This secondary canopy provided emergency backup if the main chute failed or was damaged by enemy fire. Japanese doctrine simply accepted that parachute failures would result in fatalities, with no practical remedy available. The deployment bag itself demonstrated manufacturing sophistication that Japanese facilities could not replicate. American bags used precisely designed spring mechanisms and breakaway ties that ensured consistent canopy deployment. Japanese bags relied on simpler cord ties that occasionally caused deployment failures when lines tangled or panels twisted during opening. December 1944 through January 1945. The Army Technical Research Institute, Okubo District, Tokyo. The captured American parachute arrived at the research facility packed in a wooden crate marked with priority shipping designations. Engineers prepared comprehensive testing protocols designed to evaluate every aspect of the equipment's design, construction, and performance characteristics. The institute, located in a nondescript compound surrounded by residential neighborhoods, served as the primary evaluation center for captured Allied equipment. Here, Japanese military engineers examined everything from aircraft components to infantry weapons, attempting to understand American industrial capabilities and identify potential weaknesses that could be exploited tactically. The parachute examination began with meticulous documentation. Technicians photographed every component from multiple angles, measured every seam and panel with precision instruments, and catalogued construction techniques that seemed wastefully elaborate compared to Japanese methods, focused on material conservation. The canopy material caught immediate attention from textile specialists. American parachute silk, though superficially similar to Japanese material, demonstrated superior consistency in thread count and weave density. Laboratory analysis revealed that American manufacturers maintained thread counts of approximately 250 threads per inch, while Japanese silk typically ranged from 180 to 210 threads per inch, depending on availability from different suppliers. This difference in manufacturing precision translated directly into fabric strength and tear resistance. The American silk could withstand approximately 1,200 pounds per square inch before failure. Japanese silk typically failed at 900 to 1,000 pounds per square inch. Under stress during deployment or when damaged by battlefield obstacles, this gap became critical. Japanese engineers had long understood that tighter weaves produced stronger fabric, but Japanese textile industry lacked the industrial capacity to maintain such precise standards, while simultaneously meeting demands for military uniforms, aircraft fabric, and countless other applications competing for limited silk production. The suspension line examination revealed material science differences that Japanese researchers found particularly troubling. American nylon lines stretched approximately 30% under load before reaching their breaking point. This elasticity absorbed shock forces during canopy deployment and landing impact, reducing stress on both the parachute structure and the human body. Japanese silk lines stretched only about 15% before breaking. This meant harder opening shocks that occasionally caused line failures and more jarring landings that increased injury rates. Nylon production required petrochemical feedstocks and sophisticated polymerization facilities. Japan's limited petroleum access and chemical industry capacity made nylon production at scale impossible, even if textile mills could have retooled to work with the synthetic material. Testing protocols replicated field deployment conditions as closely as possible given facility limitations. Engineers rigged the American parachute to a weighted dummy approximating soldier mass and deployed it from a tower designed to simulate aircraft exit speeds. High-speed cameras captured the entire deployment sequence, allowing frame-by-frame analysis of canopy opening dynamics. The American parachute demonstrated remarkably consistent deployment timing. From static line activation to full canopy inflation required approximately 2.5 seconds across multiple test drops. Japanese Type 98 parachutes showed more variable deployment, ranging from 2 to 4 seconds, depending on how the canopy settled during packing. This inconsistency occasionally resulted in asymmetric deployments, where one side of the canopy inflated faster than the other, causing the parachutist to spin during descent. Such spin made controlled landing approaches nearly impossible and increased injury risk significantly. The quick-release harness mechanism underwent particularly intensive examination. Japanese engineers repeatedly practiced the disconnection procedure, timing how long it took to free the harness after landing. Experienced operators could detach the American system in under 1 second with a single rotating motion. Japanese harnesses required minimum 3 to 4 seconds for even well-trained paratroopers to unbuckle all connection points. In combat situations, those additional seconds represented the difference between reaching cover before enemy fire arrived and becoming a stationary target still entangled in equipment. The harness padding revealed another design philosophy difference. American harnesses incorporated substantial padding at shoulder, chest, and leg points, where webbing made contact with the body. This padding, made from cotton batting covered with canvas, distributed suspension forces across larger body surface areas and reduced the bruising and abrasions that Japanese paratroopers routinely suffered during deployment. Japanese harnesses used minimal padding to conserve materials, accepting that paratroopers would endure discomfort as an unavoidable cost of airborne operations. The reserve parachute represented the most significant capability gap. Japanese engineers had proposed reserve chutes as early as 1937 during initial paratroop program development, but military budget constraints and material limitations prevented implementation. The American Reserve used a smaller 24-foot diameter canopy packed into a chest-mounted container that weighed approximately 8 pounds complete. Deployment required pulling a ripcord handle, a simple action that could be performed even while injured or disoriented. Testing confirmed the reserve parachute functioned reliably, providing genuine emergency backup capability. Japanese paratroopers had no such option. Equipment failures or combat damage to the main chute meant certain death. February through March 1945. Imperial Army General Staff Headquarters, Ichigaya District, Tokyo. Colonel Hayashi submitted his comprehensive technical assessment to the Airborne Operations Planning Section. His report, running to 47 pages with detailed appendices including photographs and test data, concluded with observations that military leadership found unwelcome but could not dispute. The American parachute system demonstrated clear superiority in every measurable category: material quality, construction, reliability, safety features, and ease of use. More troubling, the technological gaps identified could not be closed through Japanese industry's current capabilities. Silk quality improvements would require textile manufacturing modernization impossible during wartime. Nylon production demanded petroleum resources Japan did not possess, and chemical facilities that could not be built while fighting a losing war. Reserve parachute implementation would consume scarce materials, better allocated to primary parachutes for additional paratroopers. Quick-release mechanisms required precision metalworking capacity already overwhelmed by aircraft and weapons production demands. The assessment forced Japanese planners to confront a reality they had been reluctant to acknowledge. American paratroopers entered combat with equipment engineered for maximum survival probability and operational effectiveness, backed by an industrial system capable of producing such sophisticated gear in quantities sufficient to equip entire airborne divisions. Japanese paratroopers jumped with equipment designed to minimum acceptable standards, manufactured by an industrial base already stretched beyond capacity and deteriorating further as strategic bombing intensified and raw material access contracted. The implications extended beyond parachute technology. If American forces could engineer and mass-produce something as relatively simple as a parachute with such superiority, what did that reveal about more complex systems like aircraft, tanks, artillery, and naval vessels? Japanese military intelligence had been receiving similar disturbing assessments across numerous equipment categories throughout 1944 and into 1945. Captured American infantry equipment consistently showed superior materials and construction. Examined American aircraft components revealed manufacturing precision Japanese factories could not match. Analyzed American rations demonstrated nutritional sophistication and variety that made Japanese field provisions seem medieval by comparison. The parachute examination became one more piece of evidence in an accumulating case that Japan had entered a war against an enemy whose industrial capacity and technological sophistication exceeded Japanese capabilities by margins that could not be overcome through tactical skill, fighting spirit, or operational innovation. The strategic context of airborne operations in the Pacific Theater by late 1944 highlighted the growing asymmetry between American and Japanese capabilities. The United States had deployed multiple full airborne divisions to the Pacific, including the 11th Airborne Division that saw extensive combat in the Philippines and the 503rd Parachute Infantry Regiment that conducted operations in the Southwest Pacific. These units jumped with standardized equipment manufactured in vast quantities by American industry. Every paratrooper received identical T-5 parachute assemblies, ensuring consistent performance and eliminating variability in equipment quality. Training could focus on technique rather than compensating for equipment deficiencies. Japanese airborne forces, by comparison, remained limited to brigade-sized formations with inconsistent equipment quality. The raiding group, Japan's primary paratroop formation, numbered approximately 3,000 personnel at peak strength compared to over 13,000 in a single American airborne division. Equipment shortages meant Japanese paratroopers sometimes trained with different parachute models than they would use in combat operations. This variability complicated training and increased operational risk. The psychological dimension of equipment quality cannot be overstated in military operations. American paratroopers jumped, knowing their equipment had been engineered with multiple redundancies and safety features. The reserve parachute provided tangible psychological reassurance that equipment failure would not automatically mean death. Quick-release harnesses meant faster escape from vulnerable positions after landing. Superior materials and construction meant higher confidence that equipment would function as designed under stress. Japanese paratroopers jumped knowing their equipment provided minimal margins for error. No reserve chute existed if the main parachute failed. Harness release required precious seconds while exposed to enemy fire. Materials and construction quality varied depending on when and where equipment was manufactured. This psychological burden affected operational effectiveness in ways difficult to quantify but undeniably real. Confident soldiers fight more effectively than soldiers worried about equipment failure. The industrial capacity comparison revealed deeper strategic realities. The Pioneer Parachute Company, manufacturer of the captured T-5 parachute, was just one of multiple American firms producing parachutes during World War II. Pioneer alone manufactured over 1 million parachutes during the war years, maintaining production rates that exceeded total Japanese parachute manufacturing across all suppliers. American parachute production included not just personnel chutes but also cargo parachutes for equipment drops, brake chutes for aircraft, and specialized designs for different applications. This diversification reflected industrial depth that allowed simultaneous development and mass production of multiple specialized variants. Japanese industry struggled to maintain production of a single standardized personnel parachute design. The silk supply situation demonstrated how resource constraints shaped equipment capabilities. The United States had stockpiled substantial silk reserves before Pearl Harbor, anticipating potential disruption of Asian silk supplies. American industry simultaneously developed nylon as a synthetic alternative, with commercial production beginning in 1939 and military applications expanding rapidly after 1941. By 1944, American parachutes increasingly used nylon for suspension lines while still employing silk for canopies. This hybrid approach combined the best properties of both materials. Japan lacked both adequate silk reserves and the industrial capacity to produce nylon substitutes. Silk supply depended on domestic sericulture production that declined throughout the war as agricultural labor shifted to military service and food production. By 1945, Japanese parachute manufacturers faced chronic silk shortages that forced use of increasingly inferior materials, including rayon and cotton blends that lacked the strength characteristics essential for reliable parachute performance. The training implications of equipment quality differences created cascading effects on operational capability. American airborne forces conducted extensive training programs with thousands of practice jumps. The equipment reliability meant training casualties from parachute failures remained acceptably low, allowing aggressive training programs that built genuine proficiency. Japanese airborne forces conducted more limited training with fewer practice jumps per soldier. Equipment reliability concerns and material constraints meant training jumps were rationed carefully. Soldiers went into combat with less experience and consequently higher casualty rates during actual operations. The Leyte operation, where the captured parachute was recovered, illustrated these disparities clearly. American airborne forces conducted multiple combat jumps in the Philippines campaign, delivering thousands of paratroopers who fought effectively after landing. Japanese paratroop operations in the Philippines remained extremely limited, with most airborne qualified personnel fighting as conventional infantry because aircraft availability and parachute equipment shortages prevented airborne deployment. The few Japanese airborne operations attempted during the Philippines campaign resulted in heavy casualties, with equipment failures contributing significantly to losses. April 1945. The final report from the Army Technical Research Institute reached senior military leadership as American forces prepared for the invasion of Okinawa. The assessment recommended against attempting to replicate American parachute technology, acknowledging honestly that Japanese industry lacked the capacity to implement necessary improvements while simultaneously maintaining current production of aircraft, ships, and weapons needed for homeland defense. Instead, the report suggested focusing limited resources on incremental improvements to existing Japanese parachute designs, better quality control in silk procurement, more consistent training for parachute packers, and revised deployment procedures to minimize the impact of equipment limitations. These recommendations reflected grim acceptance that Japan could not close the technological gap through engineering innovation or industrial mobilization. The best Japanese forces could achieve was marginal improvement in equipment that would remain fundamentally inferior to American equivalents. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The broader pattern this represented troubled Japanese military analysts more than the specific parachute technology gap. American forces consistently demonstrated industrial and technological advantages across virtually every equipment category: infantry weapons, artillery systems, naval vessels, aircraft, vehicles, communications equipment, medical supplies, and countless other items all showed similar patterns of American superiority in materials, manufacturing quality, and design sophistication. Japanese industry had entered the war with capabilities adequate for regional conflict against opponents like China, whose industrial base was less developed than Japan's. Against the United States, whose industrial capacity exceeded Japanese manufacturing by factors of 10 to 20 depending on the specific product category, the gap proved unbridgeable. The parachute examination became a microcosm of this larger industrial and technological asymmetry. The combat effectiveness implications extended beyond immediate tactical considerations. American airborne operations in the Pacific Theater demonstrated capabilities Japanese forces could not match. The United States could drop entire battalions of paratroopers with heavy equipment, including jeeps, artillery pieces, and supplies sufficient for sustained operations. Japanese airborne doctrine, by contrast, assumed paratroopers would conduct brief raids before withdrawing or linking with conventional ground forces. The equipment and airlift capacity to sustain independent airborne operations simply did not exist in Japanese forces. American cargo parachute technology, briefly examined during the captured equipment assessment, revealed another significant gap. The United States had developed specialized cargo chutes capable of delivering loads up to 2,000 pounds, including artillery pieces, vehicles, and supply containers. These systems used multiple parachutes in clusters with sophisticated rigging that ensured controlled descent and minimal damage to cargo. Japanese forces possessed no equivalent capability. Supply drops to Japanese forces used improvised methods with high loss rates and frequent cargo damage. The few attempts to airdrop heavy equipment resulted in such poor success rates that Japanese commanders generally avoided airborne supply operations entirely, relying instead on ground transport, even when air delivery would have been tactically advantageous. The personnel accounts from Japanese paratroopers who examined American parachutes captured during combat operations provide revealing insights into how individual soldiers perceived these equipment disparities. Sergeant Kimura Yoshio, a veteran of the Palembang operation who survived the war, recorded in post-war interviews his reaction to seeing captured American parachute equipment in early 1945. The first thing you noticed was the quality of materials. The silk felt different, tighter and stronger. The stitching was perfect, every seam identical. Our parachutes, especially by 1945, showed inconsistent quality. Sometimes the silk was good, sometimes you could see thin spots. The harness webbing on American equipment was thicker and had padding. Ours cut into your shoulders during descent. You learned to accept the pain, but seeing that they didn't have to tolerate it made you angry. Not at the Americans, but at our own leadership for sending us to fight with inferior equipment. Such sentiments, expressed privately among combat veterans, reflected growing awareness among frontline soldiers that Japan's military leadership had committed forces to operations without ensuring adequate equipment to compete effectively against better-equipped opponents. The morale impact of this realization, though rarely documented officially, contributed to the deteriorating fighting spirit observed in Japanese forces during the final year of the war. The reserve parachute question particularly troubled Japanese paratroopers. American prisoners occasionally discussed their equipment during interrogations, and word spread through Japanese units that American paratroopers carried emergency backup chutes. Japanese soldiers jumping without reserves understood intellectually that parachute failures were rare, but the knowledge that their opponents possessed backup systems while they had none created psychological stress that affected unit cohesion and morale. Some Japanese paratroopers expressed fatalistic attitudes, believing their survival depended more on luck than equipment reliability. Such fatalism, while sometimes portrayed as fighting spirit by Japanese propaganda, actually reflected demoralization caused by inadequate equipment and recognition of industrial inferiority. The technical assessment process itself revealed Japanese military culture's strengths and limitations. Japanese engineers conducted thorough, scientifically rigorous examination of captured American equipment. Their reports documented findings with precision and honesty, reaching conclusions that contradicted official narratives about Japanese technological parity with Western powers. This intellectual honesty among technical specialists represented Japanese military culture at its best, prioritizing factual accuracy over ideological convenience. However, the military leadership's response to these assessments revealed systemic dysfunction. Rather than fundamentally reassessing strategic commitments in light of clear evidence of industrial and technological inferiority, Japanese command structures continued operations as if material disparities could be overcome through fighting spirit and tactical innovation. Technical reports documenting American superiority were acknowledged, but not allowed to influence strategic planning in meaningful ways. The parachute assessment joined files of similar reports about American tanks, aircraft, artillery, naval vessels, and other equipment that collectively painted an undeniable picture of overwhelming American material advantages. Yet, strategic decisions continued to be based on assumptions about Japanese spiritual superiority and American weakness that these reports comprehensively contradicted. This disconnect between technical reality and strategic planning represents one of the war's great tragedies from the Japanese perspective. Competent engineers and analysts provided accurate information about capabilities and limitations. Military leadership failed to incorporate this information into realistic strategic planning, instead pursuing operations that technical assessments clearly indicated could not succeed, given existing equipment and industrial capacity. The post-war fate of Japanese airborne forces reflected the limited role they played during the conflict's final stages. The Raiding Group conducted its last significant airborne operation in May 1945, with small-scale raids against American air bases in Okinawa. These operations achieved minimal tactical results while suffering heavy casualties, confirming assessments that Japanese airborne capabilities had deteriorated to the point where conventional deployment proved more effective than specialized airborne missions. Most paratroop-qualified personnel fought as elite infantry during the final battles for the home islands, their specialized training and equipment becoming irrelevant as Japan shifted to defensive operations where airborne deployment was impossible. American airborne forces, by contrast, continued expanding through war's end. The 11th Airborne Division performed occupation duties in Japan after surrender, and American paratroopers participated in victory celebrations wearing the same T5 parachute harnesses that Japanese engineers had examined with such concern. The symbolic contrast was striking. American soldiers with standardized high-quality equipment produced by an industrial system operating at peak efficiency. Japanese soldiers, including elite paratroopers, equipped with increasingly inferior gear manufactured by an industrial base, collapsing under sustained bombing and resource exhaustion. The captured parachute itself, that single T5 assembly examined so thoroughly in Tokyo during winter 1944 through spring 1945, survived the war intact. Research Institute personnel packed it carefully when facilities evacuated ahead of American bombing raids, and it eventually ended up in storage at a warehouse in Yokohama. American occupation forces discovered it during post-war equipment surveys, recognizing the serial number and unit markings. The parachute was returned to United States custody and spent decades in storage at various military facilities, before eventually being transferred to the Airborne and Special Operations Museum at Fort Liberty, North Carolina, where it remains in the collection, though rarely displayed publicly. The lessons learned from examining American parachute technology influenced Japanese post-war military development in subtle ways. When Japan established the self-defense forces in the 1950s, airborne units received parachutes manufactured using American technology and often purchased directly from American suppliers. Japanese industrial recovery after the war included rebuilding textile manufacturing with modern equipment capable of producing nylon and other synthetic fibers. By the 1960s, Japanese industry could manufacture parachutes to international standards, but the initial post-war period required imported American equipment. This dependence on former enemy technology for essential military equipment represented tangible acknowledgement that pre-war Japanese industry had indeed lagged behind American capabilities in ways that wartime propaganda had concealed, but technical assessments had clearly documented. The broader implications of the parachute technology gap extend to fundamental questions about industrial capacity and military effectiveness in modern warfare. World War II demonstrated repeatedly that industrial sophistication and manufacturing capacity determined outcomes more decisively than fighting spirit, tactical innovation, or operational skill. Nations with mature industrial sectors producing high-quality equipment in vast quantities defeated opponents whose industries could not match either quality or quantity of production. The parachute represents a relatively simple technology compared to aircraft, naval vessels, or complex weapons systems. Yet even this straightforward equipment revealed massive gaps in industrial capability between the United States and Japan. American industry could mass-produce parachutes with sophisticated safety features, consistent quality, and advanced materials. Japanese industry struggled to maintain production of basic parachutes with inferior materials and inconsistent quality. This pattern repeated across virtually every equipment category, from rifles to battleships. The mathematical realities were brutal and decisive. American industry produced approximately 297,000 aircraft during World War II. Japanese industry produced approximately 76,000. American shipyards launched approximately 175 fleet and escort carriers. Japanese yards launched 25. American factories manufactured approximately 88,000 tanks and self-propelled guns. Japanese factories produced approximately 6,000. These production ratios, ranging from 3 to 1 to 10 to 1 depending on equipment type, reflected industrial capacity differences that could not be overcome through any amount of tactical skill or fighting spirit. The parachute technology gap, though less dramatic than these massive production disparities, revealed the same underlying reality. American industrial maturity and manufacturing sophistication exceeded Japanese capabilities by margins that proved strategically decisive. German technical assessments of captured Allied equipment, including American parachutes examined after airborne operations in Europe, reached similar conclusions about industrial and technological gaps. German engineers noted the same superiority in materials, construction quality, and design sophistication that troubled Japanese analysts. However, German industry possessed greater capacity to respond. developing improved parachute designs including reserve chutes that saw limited service late in the war. Japanese industry lacked even this capability for incremental improvement. The industrial base had deteriorated too severely by 1944 for meaningful equipment upgrades regardless of technical knowledge gained from examining captured American gear. The comparison between Japanese and German responses to similar technical intelligence highlights how industrial capacity determines military possibilities. Germany, with more developed industry and better resource access through 1943, could sometimes respond to Allied technological advantages. Japan, with less developed industry and severe resource constraints throughout the war, could only document American superiority without possessing means to close gaps through domestic production improvements. The human cost of this industrial disparity cannot be calculated precisely but was undeniably severe. Japanese paratroopers jumped with equipment that provided narrower safety margins, suffered higher rates of equipment-related injuries and fatalities, and faced psychological stress from knowing their equipment was inferior to what American opponents used. These factors contributed to operational casualties and reduced combat effectiveness in ways that compounded tactical disadvantages Japanese forces faced across all domains. American paratroopers, jumping with equipment engineered for maximum safety and reliability, suffered fewer equipment-related casualties and fought with confidence that their gear would function as designed. This translated directly into operational effectiveness and mission success rates that Japanese forces could not match. The post-war careers of American and Japanese paratrooper veterans reflected these wartime experiences. American airborne veterans generally viewed their service proudly, with equipment quality being one aspect of American military superiority they witnessed firsthand. Japanese paratroop veterans, including those who examined captured American equipment, often expressed frustration in post-war interviews about being sent into combat with inadequate gear, despite leadership's awareness of equipment deficiencies. Some Japanese veterans became involved in post-war defense industry development, applying lessons learned about the critical importance of equipment quality and industrial capacity in modern warfare. Their experiences informed Japanese post-war military planning and contributed to decisions to prioritize equipment quality, even when that meant accepting smaller force sizes. The captured parachute examined in Tokyo during winter 1944 through spring 1945 represented far more than a single piece of equipment brought back for technical evaluation. It was physical evidence that American industrial capacity and engineering sophistication operated at levels Japanese industry could not approach regardless of effort or commitment. Every design feature that improved paratrooper safety, every material choice that enhanced reliability, every manufacturing technique that ensured consistent quality proved that American military power rested on industrial foundations that exceeded Japanese capabilities by decisive margins. Japanese engineers understood this through systematic examination and testing. Their detailed reports documented findings with scientific rigor. They reached accurate conclusions about American advantages and Japanese limitations. But understanding a problem and solving it require fundamentally different capabilities. Japanese industry in 1944 and 1945 lacked capacity to implement improvements even when engineers knew exactly what changes were needed. American industry had built quality and reliability into military equipment through decades of manufacturing experience and simply extended those proven principles to specialized equipment like parachutes with remarkable success. The technological and industrial gaps revealed through examining a single captured parachute illustrated why Japan had already lost the war materially, even as fighting continued. American productive capacity could not be matched regardless of Japanese technical knowledge or tactical skill. The equipment carried by individual American soldiers, including some as specialized as a parachute, demonstrated industrial sophistication Japanese forces could document but not replicate. Every kilogram of higher quality silk, every centimeter of better stitching, every design feature that improved safety or ease of use represented accumulated industrial experience and manufacturing capacity that Japan simply did not possess. The war's outcome had been determined by industrial mathematics long before specific battles were fought. The captured parachute examination merely provided one more data point, confirming what Japanese technical specialists had reluctantly concluded. American industrial power exceeded Japanese capabilities by margins that made eventual defeat inevitable, regardless of fighting spirit or tactical innovation. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.